Chapter 17, the intensity of sound waves and the decibel scale. Intensity of sound and decibels. So we're going to take a source of light, a source of sound, and say, okay, the source of sound is putting out certain power in watts, and the power is a measure of how much power and energy that it's putting out, right? And then that power is spreading spherically in all directions. So as I'm talking, or if you're listening to a speaker, right, the sound is spreading spherically in all directions through the air, right? So the intensity that a person hears at a certain location, the intensity is going to be equal to the power divided by the area. So it's units of watts per meter squared. Right? So over the total surface area that has spread out. So if the sound wave is spreading out spherically, right, the surface area of a sphere is 4 pi r squared. So r is the distance from where you are to the source of the sound wave. So the intensity is going to be P over 4 pi r squared. And then this is going to give you watts per meter squared. Right? That's going to be the intensity of the sound wave. And then the decibel scale takes this intensity and converts it into a logarithmic scale. So decibels is sometimes written dB, or you could even call it B. And then that one is equal to the log, 10 log of the intensity divided by some reference frame intensity known as I0, right? So I0 is equal to the threshold of hearing, 10 to the minus 12 watts per meter squared. So that's, supposedly they call that the threshold of hearing. So if something is that intensity, it barely has enough intensities to kind of, the way that we hear something, right? It comes to your eardrums and it vibrates your eardrum with a certain intensity, then you hear something is going on, right? Then your brain converts that into a sound, a measure of loudness, right? So if it's something like this, then we call that threshold of hearing. That means you barely hear it. Threshold of hearing. Of course, the threshold of hearing is different for different human beings. We can't say everybody has the same threshold of hearing, because as you age, your threshold of hearing probably increases, where you can't hear something that you used to be able to hear when you were younger, right? So you say, what did you say, right? So that means our threshold of hearing is increasing, and then anything below that, we can't hear. So someone has to speak louder, right? So this is probably threshold of hearing when a person has really, really good, we can call that like 20/20 vision. So this would be the equivalent of, if you could hear this, you have 20/20 hearing, right? So if in intensity, if the intensity that this person is hearing is equal to I0, right? If I equals I0, then what would be the decibel scale intensity? So we can convert that to decibels. The decibels dB would be what? This is just the D or dB is different ways of writing it, but dB is short for decibels, right? And this is, you can just say decibels. So then that would be 10 log of, then the I would be I0, right? I0 over I0. And then that would be log of 1. So log of 1 is 0, right? So then that would be 0. So if I equals I, 0, and we can say we can make a little table here. And then we can say, okay, this is the intensity. So we can say on the top, this is the intensity. This is the decibel scale intensity corresponding to that. And then this is equal to the, we can say, the measure of how loud you would interpret that. The loudness, we can say L. So if I equals I0, the decibels of that is 0 decibels. And the measure of loudness would be very, very, almost no loudness at all. So we can just say L naught, right? And then we can say, well, what if the intensity is 10 times that? If I is equal to 10 I0. Okay? So then a sound wave that is 10 times as intense as the threshold of hearing would be what on the decibel scale? So then dB would be 10 log of, then we put here 10 I0 over I0, right? And then that would cancel. Log of 10, base 10 would be 1, right? So 10 times 1 would be 10. So then the decibels here is 10. So if you're 10 times the intensity of this, now you're 10 decibels on the decibel scale. And then the loudness is a measure of how loud your ear would interpret that. What it ends up is that the loudness is more of a psychological interpretation of your brain saying, oh, how loud does that appear to me? So it ends up that for every 10 decibels, a sound wave you will hear it about twice as loud. So that would be twice as loud as the threshold of hearing, right? So, but this is an approximate number. Okay, so now if I equals to 100 I0, right? Then you could say here dB is going to equal what? 10 log of 100 I0 over I0, right? Then you're going to have log of 100, which is going to be 2, right? 2 times 10 is going to be 20. So then this is 20. So every time the intensity is increasing by 10-fold. So now this is 100 times the threshold of hearing, but on the decibel scale it's only 20, right? And then how loud will that appear? That will appear twice as loud as this or 4 times as loud as that. So every time you're going up by 10, it's feeling like the sound is twice as loud. So then we go to here, 1000 I0. So of course you can see here it's going to be 30. This is going to be 8 times as loud as that. Right? So you can see if you're comparing the 20 to a 30, 30 sounds twice as loud as a 20. Right? You just divide this by this, you get 2. Right? So then we can keep going all the way to an intensity that's trillion times as intense as the threshold of hearing. 10 to the 12th I0. Now we're going to the really loud sounds, right? So if I put here 10 to the 12th, what are you going to get? 10 to the 12th I0. Then I0 is going to cancel. And then log of 10 to the 12th, 12 is going to come down. And then 12 comes down, multiplies by 10, and you get 120. Right? So that's kind of on the loud end. I believe this is called the threshold of pain, 220 decibels. Threshold of pain. Now, what would the loudness be? Well, you can keep doing this 4, 8. How many times L0 would it be? Can we do a generalization? 2 to the power of what? Every 10 was a factor of 2 to the power of 12, right? Let's see here. Yeah, because 10 was 2 to the power of 1, 20 was 2 to the power of 2, this is 2 to the power of 3, so this would be 2 to the power of 12. So approximately 2 to the power of 12 L0. What is that? That's a lot, right? $4,096 times as loud. So 4,096 times as loud. So the threshold of pain is 4,096 times as loud as the threshold of hearing. Right? Let's see here.